This is an amazing engine. Built in 1821, used waste coal to operate at a 51-inch stroke, 33-inch bore. And you can see the output of it along that rocker cylinder. And down runs this big flywheel. I'm not sure what those wheels were for. It don't talk a lot about detail on it. Pretty interesting machine. I'm assuming this is a counterweight over here. This is a Dixon engine built in 1811. Drove an English silk mill until 1928. It is a 12 horsepower engine. Has a 17-inch bore and a 36-inch stroke. See the flywheel on that thing. I'm assuming that's the governor. All right, here's another example of a big engine. These are considered beam engines, by the way. This one uses steam, and they say that they use the steam twice. First in a small diameter high pressure cylinder, and again in a larger diameter low pressure cylinder. It was built by Thomas Warren in 1850. This is the power section of the museum, by the way. Over here is a cycloidal engine built about 1805. There's also a steam engine. Use pistons and cylinders. Got a lot to read about there, but I'm not sure I understand any of it. I'm just going to kind of get some video of what these things look like. You imagine the machining that must have been involved in building these things. This one here is known as the Grasshopper engine, built around 1806. It had the fulcrum at the end of the beam instead of the center. See, these are at the center. That one is there at the end. Don't say what this was powered by, but I'm assuming steam as well. Precision lathe, built in 1816. I was going to try to get some good video of this set up, but it's just too massive to do so. So I'm just going to try to walk around it and get as much of it as I can. It's a Newcomen engine, built around 1760. Oldest surviving steam engine in the world. Used to pump water out of a deep mine in England. You can see the massiveness of that thing. I'm assuming that's the boiler over there. Brings the steam in. That looks to be the barrel and the piston. Pump jackets comes across, operated off that beam through those massive chains. Pretty impressive. I'm just going to try to capture this. This is an explanation of the engine generator from Highland Park in 1915-1916 by the, it said that Ford's needs by 1919 had grown to where they had 9 of these generators. It used a combination of industrial combustion and steam engine. Total power was 4,000 watts, 250 volt direct current, 15,000 amps, run at 80 RPM. Interesting. I'm going to back off now and try to get some video of it. We'll start by down here and then walk our way down. I think it's just going to be up too close to be able to see much. You can see down underneath a lot of the piping, and I'm assuming that's the generator down there. Oh, okay. Yeah, maybe we can get a little bit better look at it. Still not sure we're going to be able to see much. Let's try to get a picture of this right here. This would be the steam side, I think. Check out the flywheel on that thing. Wow. And I assume that's the generator part itself, actually. Be nice if they had somebody doing a tour explanation of this. So that's be the camshaft. And now we're down, I'm assuming that to be the generator end, where the power is actually generated. Check out those crank rods. There's a display of all of these things in use or installed in the powerhouse. And if we go over here, you can see this was the powerhouse that powered Ford's Highland Park. And the layout of the generators. Nice set of chrome tools. Wonder if they use those. Wow. Nice set of wrenches, huh? More view from underneath the generators. I don't know how many people it took to keep these on running. So, I mean, that's the boiler. And I had quite a few people dedicated just keeping the boiler running. Pretty impressive. This is a generator built by General Electric, 1897. It provided 76 kilowatts, 900 run at 900 RPM, 2,300 volts of AC. It powered the Bunker Hill and silver mine in Idaho until 1897. It was installed in 1897, was replaced in 1906 by the big engine you see behind us. That is a water turbine engine. Water comes in and drives the turbine, which then drives that big generator. It produced, 1,300 kilowatts, 4,000 volts. And supplied power to the silver mines 100 miles away in Idaho. It was installed in Washington by the Washington Water Power Company in 1903. Ran until 1990. There's enough power to light 32,540 watt bulbs. I'm gonna, whoops. Now we're standing where they got a cutaway view of the turbine wheels, and I'm not sure what the water flow was, but I'm assuming it came in from the top, looking at the direction of the cups. Came along those rails probably and drove the turbine. Fantastic piece of machinery. It's a marine steam engine. I don't have a lot of detail on it, but here's a kind of a model of it. You can see the output driving the propeller. See what it says. It's a marine steam engine from 1875. Produced 400 horsepower at 72 RPM. This is interesting. I'm gonna see if I can get just a copy of image of that and try to talk about it. This is a steam engine driving generator that was used in the by Edison to produce direct current. Notice the three different size pistons. One is an 18-inch bore, the other is a 27-inch bore, the third is a 40-inch bore. The 30-inch stroke produced 200 kilowatts. 110 volt DC. This was a generator from New York's, one of the New York power stations. I think it was Pearl Street Power Station. The Edison General Electric Company, 200 watts, a kilowatt. And of course, General Electric stayed in Schenectady, still there today. Everything I got to go by their headquarters there once. This is a stationary steam engine, somewhere around 1888. I'll get my centuries right one of these days. It high-speed engine ran at 300 RPM. Produced looks like 90 horsepower. 8-inch bore and a 16-inch stroke. And it would have powered a generator. Edison says Edison used these engines in his first permanent power stations. This is quite interesting. It is they call it a Corning glass ribbon machine. It actually created a ribbon of glass and then blew it into molds to make light bulbs. You can see a stack of light bulbs, or light bulb containers. I guess they would then put the elements or filaments in it. Pretty interesting piece of machinery. Says they made 600 to 700 bulbs. What did it say, a day? I believe it was. No, 600 to 700 glass castings a minute. Reduced the cost of light bulbs, would put a lot of glass blowers out of business. Well, that's what happened with technology. This is a stationary engine, steam engine, from about 1855. Notice the design, the arches, the Gothic structure. Big machine. It don't say what kind of power it produced. Apparently it was in Philadelphia at some point. Oh, here we go. It's 150 horsepower, 132 RPM, 36-inch bore, and 72-inch stroke. We'll walk around the other side. Got a better view of it. Not only was it quite an engine, but it was a piece of art as well. A number of other engines and generators along the way. This one from about 1862. An interesting display. It's a model machine shop with a boiler, the steam engine, and the steam engine driving the line shaft, which then in turn drove all of the machining equipment. It's a really neat little design. Somebody put a lot of work into that. A lot of work. Wish it was operating. Be fun to see. This is a Noble Green engine from about 1880. Apparently he and Corliss got in a big patent feud, and George Corliss, I believe it was George, won out. That was his design. Apparently Corliss felt like he stole his design. This engine was used in Kirby's Mill in Willimantic, Connecticut. 90 horsepower, ran at 90 RPM, got an 8-inch bore and a 30-inch stroke. This is a 1959 Corliss engine. Produced 300 horsepower, 75 RPM. Bore was 24 inches with a 60-inch stroke. Check out that flywheel. Wow, a lot of material in that flywheel. They're going to demonstrate this, I think, at 2 p.m. today, so this old boy's going to be here to watch it. I'm sure it won't be ran on steam. Kind of it for the steam engines, except I'm going to do a video, if I can, the operation of the big Corliss engine at 2 p.m. Right now I'm going to go over and look at the aircraft section. They're getting ready to demonstrate this big old engine. We're going to see what things look like.
Corliss actually put his on the throttle. So how that would have worked, if this is going too fast, they would have went outward. There's these two speed pieces right here. Those would have lifted and cut some of the speed so you were maintaining the same speed. Because since this was being used for material, you didn't want to be breaking threads, that was going to cost you more money. This is going to cost about $10,500 to buy. The whole thing behind this was that it's actually supposed to save you about 40% of your energy costs. Corliss did have a gentleman ask me if that was true. So he actually gave him one on consignment and told him to pay the difference. At the end of the year, the man owed him $19,400. So it was very much more efficient. Something else cool about this, it does have a double valve system, which makes it run smoother. The flywheel governor being where it was a patent that Corliss fought to keep until he died in 1918. If you got other questions, just let me know. That's what I'm here for.
It's very solid. Very solid.
Yeah, it's very quiet. It would not be as quiet as the battery. Yeah.
You know it's actually fuel.
So we are running it off of compressed air. There is a compressor in the basement about this tall. When I started, it gives me about 30 psi, and then the entire time I'm running it, it continuously gives it 5 psi. So just needs a little bit of boost to keep it going since it weighs so much.
We noticed the electric motor on the
So that is fun because we like to stop this thing, and there's cars back there that kind of put bowling pin. The easiest way to stop it and start it again is to get that at midnight, so right there. And then you gotta push it over. Sometimes we don't do a very good job at stopping it, and then that little motor back there grips onto the flywheel, and they can move it to where it needs to be.
top dead center.
Yep.
Gotcha.
What was that? Take
What would the typical RPM be on it?
10 times faster.
What the typical RPM of this?
It'd be about 75 to 80. We're running it between 7 and 8. There's a really cool diorama over there that kind of shows you what it would have looked like set up in the factory setting. That diorama is also cool because this building used to be a school in the 30s, and that was built by some of the kids that used to go to school here. It was a trade school for a short amount of time. And then Henry Ford just had too much stuff and people wanted to see it, so we turned it into a museum.
Very neat. Thank you.